Welcome to clickmyproject.com.
Our product title is a low energy machine learning classifier based on clocked comparators for direct interference on analog sensors. Now we are going to discuss about our product abstract. In our process, a comparator is a device that compares two voltages or two current and provides the output which is larger. A comparator used to maximum the speed of power efficiency of ADC analog to digital converters. Comparator has two input terminal and one output terminal. In this process, the comparator and comparator's terminals is modified the circuit level by adding a few transistors for low power consumptions, and the whole designing of using based on Cmos technologies, because Cmos technologies offer less power dissipation and smaller noise level and high package of densities. The analysis of the delay and comparators is presented the double tile modifications process, so low power consumptions. The fast operations even small supply voltages by adding a few transistors reduce the delay time also. The reductions of delay time will be provide some power consumptions. These designs to achieve some power consumption, they modify the circuit added transistor may consume some powers. We have to concentrate of the complexities for the reduced power consumptions. We are going to propose the design for the CMOS comparators. This based on the low voltages bipolar sizing CMOS techniques. The designs they may have achieved a small amount of power consumption. They reduce the requirement of supply voltages which provide for the delay time. We focus the designs achieve the CMOS comparators using the low voltages bipolar sizing the CMOS techniques. That mean for the design, the comparator design is based on the bipolar CMOS technologies. This combination of the bipolar and CMOS technologies, the CMOS circuits offer high speed, high gain and low output resistance, which are the excellent properties of the high frequency analog amplifiers. In the CMOS technologies, the CMOS technology have offer high input resistance and excellent construction assemble and low power logic gates. So we choose the bipolar method, and the two voltage source are applied for the designed architectures and compare to both inputs, resulting the high source of the output. Finally, this process provide to reducing the delay time and result of low power consumption. Now we are going to discuss about the product flow diagram. Our process mainly we focused for the CMOS based the comparator. The first CMOS design. The CMOS design has in combination of PMOS and NMOS the process, and we have compared the input for the voltages to level high and low level. We get the comparator based for the double tile design and then bipolar designs. Why we are using the bipolar designs? Because we have focused the design architectures for that bipolar sizing the CMOS techniques. These design techniques mainly for the combination of for the bipolar and CMOS technologies. The CMOS and bipolar offer the high speed, high gain and low output resistance based on the we have excellent properties for the high frequency and amplifiers. So we using the bipolar designs and double type designs. The adding the few delay times will provide the power consumption. The design that achieve the some power consumptions to modify the transistors that may consume the some powers. And then we going to for the comparator check. This modified the transistors concentrate of the complexity to reduce the power consumptions. Here we go into the for the process design for the CMOS comparators based on the low voltage bipolar sizing CMOS techniques. The design have thus achieved a small amount of the power consumption based on the comparator checks, and we lost finally getting for the result for the analysis spots. So we give the for the input for pulses and bits. We go into for using the CMOS design and then architecture designs. These are mainly for the based on comparator architectures. These architectures we have combination of the bipolar designs and double type designs control systems. We using the some transistors based on the S1 like PMOS, and then S2 is NMOS. We have combination of the CMOS process. We going to give the some the S1 input process, get output the write process in the S1 and read process for the S2 CMOS, and then we go into for the control based on the feedback control systems. This control system based on the how we input in write and read operations based on the comparators checking process. Now we are going to discuss about our product running procedure. In our process, the comparator we have implemented based on the Tanner EDA process tool, and then we implemented the based on the bipolar designs and double tile designs. So first we are going to design for the architecture of CMOS design. So in the demo CMOS design, we have combination of NMOS and PMOS process. We have getting from the library for the latest Tanner process library. So some we are editing for the some what we want need for the NM. We utilize that NM. We have getting the library process. After the complete this design, we are going to follow some setup simulation process. So first we going to for the simulation setup for the the transient Fourier analysis for giving the some timing process, so which we need for the clock and the enable time and the stop time and the starting time. We give the some basic analysis spot for the based on timing. This setup this type of we have implemented. After we go into for the running process. So we have designed the comparator design based on the cell 0 based comparator designs, and just we go into the running the process. We getting the two type of simulation process, T space and W edit waveform process. So W edit waveform process we give the some analytic for the graphical process. This is the output process based on the comparators. This is the input VN clock. So this is the enable pin for that feedback process. This is the output for the comparator process. So we have giving some comparators based on the input based on this clock pulses, and then input process based on, and then this is the neutral point for that reading point and reading edge point for the pulses giving that. So this is the waveform method. We give the some comparator output process. After we giving the T space based on we are giving the some part for that. So this is the timing requirements for that total timing for this process. So mainly we going to the power analysis and delay analysis. So we need some procedure for that. So export and export Spice Pro, we need for the export the file. After we go into the open the where we want having the store this process, we have implemented the analyze the out file. This is the main cell 0 T space process. We going to the implement the out file for the processing. How do we get the power and delay process? So we need the OUT file, out file. This open, it will be the some analysis spot for the power analysis. So this is the power analysis result based on the time, and then this is the timing process. So we have implement the main concept by the comparator process. So based on the CMOS and bipolar designs process, and we get the some output for the power analysis main method for low power consumptions and low delay process. Thank you watching our video.